call them roots. There are a couple other names. We can also call them solutions. We can call them zeros. We can call them x-intercepts. All of those mean the same thing. It's just your solution. So there's a couple different names for it. So we can call them roots. We can call them solutions. Roots, solutions, zeros. Or x-intercepts. All of those mean the same thing. So you can really use those words like interchangeably. Doesn't matter which one you use, but it's just where it crosses the x-axis. So there are 3 different types of solutions that you can have. You can either have 2 solutions, 1 solution, or no solution. So if you have 2 solutions, that means your graph crosses the x-axis twice. So it could look something like this. And the solutions would be the 2 points where it crosses. This is my x-axis right here. It could be a happy face graph or it could be a sad graph. It doesn't matter. But if it crosses twice, it's got 2 solutions, and these 2 numbers are your answers. If it only has 1 solution, then that means it only crosses the x-axis 1 time. So again, it could be a positive graph or it could be a negative graph. But again, the solution is it's only going to cross the x-axis at 1 point. And then if there's no solution, what do you think that's going to look like? It's just in one of the quadrants. Yeah, exactly. So maybe it's something up here. Maybe it's going down over here. It doesn't really matter, but it's just never, like Jada said, it's never going to touch that x-axis. So it's in one of the squares, one of the quadrants. Good. So what we're going to do is we're going to practice graphing like we've already done. Okay, everything's exactly the same, except this time around, we're just going to be looking for the solution. So we're still going to have to graph the same way. We're going to start by finding our A value, our B value, and our C value. Nothing's changed there. The only thing that we're looking at this time is where does it cross. So let's take a look at number 1. Your equation is y equals x squared plus 4x minus 5. Is this a happy graph or a sad graph? Happy. This is a happy graph. Okay, let's start by just identifying our A, B, and C. What's your A value? 1. What's your B value? 4. And what's your C value? -5. Okay, who remembers the equation to find the axis of symmetry? Good, -b over 2a. This is your axis of symmetry. Okay, but be careful. So -b is what? -4 over 2 times a. 2 times 1. So it's -4 divided by just 2, which gives you -2. Okay, so we'll start by graphing the -2 on our graph. So remember, this is where you got your vertical line. So at -2, dotted line, whatever you want, or a straight line through. There's my axis of symmetry at -2, or you can do a straight line through, I don't care. A little easier to see that way. Okay, so this was my first x value is -2. What do I have to do to find the vertex? Plug in -2 to the equation. Yeah, there's not a lot of space, but anywhere I see an x, I'm going to plug in a -2. -2 squared plus 4 times -2 minus 5. Okay, what should I do first?
Well, do the -2 comma -2 plus 4 times -2 minus 5.
Good. So -2 squared means -2 times -2. +4. 4 times -2 is -8. And then I bring down my -5. So 4 minus 8.
I got -9.
-9, perfect. There's your vertex. -2, -9 right here. Okay. And again, we know it's a happy graph. So now we just go through and we're plugging in some numbers. What's always the easiest and best number to plug in? Heck yeah, 0. So if we plug in a 0 for x, if I plug in a 0 right there, this is going to go away. 0 squared goes away. You're just left with, yeah, -5. Okay. And then you should be able to find its mirror point. So just go over. I went over 2 to the right, so I'm going to go 2 to the left. And what point is that? -4, -5. Good. Now, I'm trying to find the solution. So the solutions are where my graph crosses the x-axis. Is my graph crossing the x-axis yet? Has it touched the x-axis so far?
No.
No, that means I'm going to have to plug in another number because it hasn't crossed over just yet. So what's another easy number to plug in?
1.
Okay, let's plug in a 1 then. Kind of run out of space, but 1 squared gives me 1. What is 4 times 1? 4. And then bring down my -5. So 1 plus 4 is 5. And 5 minus 5 is 0. Hey, 1, 0 is right here. Hey, is that crossing the x-axis?
No. Yes.
Yes, it's right on the x-axis. Which one would be its mirror point? 1, 2, 3. Whoa. 1, 2. What number is that? That is not -4.
Oh wait, what's
Yeah, -5. Counting's hard. -5, 0. Okay. So your solutions are the 2 points that are on the x-axis. What 2 points are on the x-axis? Okay, so these right here are your solutions. There are 2 solutions. And when we write down the solutions, we don't need to write it as a coordinate. The only thing we need to write down is the x value. So I write it, it looks like this. You write x equals, and then when we write our solutions, we put them, have you ever seen the brackets that are kind of like the curly ones? We put them in a curly bracket, looks like that. So my numbers are -5 and +1. Yes. Yes. To the best of your ability, give it a try. The more you do it, the better you're going to get at it. Yeah. Okay, so there were 2 solutions for that one. There you go. You figured it out. Graphing, man.
That's a lot of work.
It is a lot of work. I'm going to show you a faster way tomorrow. But for now, we're going on with graphing it. Yeah, go for it. Okay, I'm going to kind of like bounce around because I want us to be able to get to the back fast enough. So let's do number 3, and then we're going to flip to the back. All right, first and foremost, happy graph or a sad graph? Sad graph. All right, let's write our A, B, and C values. What's your A value? -1. What's your B value? 2. What's your C value? Good. Yeah, but we'll worry about that tomorrow. I don't know. Okay, A, B, C value. What should I do now? -b over 2a. Good. The axis of symmetry. Perfect. Okay. Now what? Good. And what's negative?
I mean, positive 1.
There we go. Positive 1. Good. So negative 2 divided by negative 2 is positive 1. So now we come to our graph. At positive 1, we put a vertical line. Huh? Okay. What's my next step? Plug it in, plug it in. Okay, now remember, when you go to plug it in, what should be the very first thing that you write? You've got the negative sign there. So make sure you put a parentheses with the negative 1. And then we'll plug in everything else. So instead of x squared, I'm going to write 1 squared plus 2 times parentheses 1 minus 3. Okay, so when we come over here, remember you have to do the exponent first, and then you can multiply by negative 1. So what is 1 squared? 1. And what's 1 times negative 1? Yeah.
Why did you put negative 1 first?
Because there's a little negative sign right here.
I thought you put like 1 already.
So I'm putting in the 1 for the x, but this is saying there's also a negative 1 in front of the x. We just don't write the 1 that's there. So anytime you see this little negative symbol in front, you have to put a negative 1 there, because that's saying that your graph's going down. So if when we go to put another number in, and when we go to put a 2 in or a 3 or whatever, you're still going to put negative 1 first because there's a negative sign, but then you'll put like 3 squared. But this negative symbol has to go first. There's an invisible 1 there. Good question. Okay, 1 squared is 1 times negative 1 is negative 1. Positive 2 times positive 1 is 2. And then minus 3. So what is negative 1 plus 2 minus 3? Maybe you put in your calculator. What? Negative 2. Good. 1, negative 2. So I'm going to come over here to my graph, and I'm going to plot the point 1, negative 2. All right, now we'll do one more. And what's the best number to always plug in? 0. So let's plug in a 0. So when you plug in a 0, what happens? This is your vertex. What are you left with when you plug in a 0 here and a 0 here? You're just left with negative 3. So everything cancels except for that constant at the very end, your C value. So 0, negative 3 means you're at 0, you just go down 3. And what would be its mirror point? 2, negative 3. Now, without doing anything more, you know this graph is a sad graph, right? So it's going to keep going down. Is your graph ever going to touch the x-axis right here? No. So if it never touches, what does that mean? There's no solution. So this graph does not touch the x-axis. So because it doesn't touch it, that means this is no solution. So when we write that, you can physically write the words no solution. That's fine. You can actually physically write it out. Or if you don't want to write it out, you can look, if you write it like this, we put x equals, and essentially it's like a 0 with a line through it. No solution. Yes.
I'm sorry. How did you get the 2 in the 3?
Okay. So I did, when I plugged in 0, right? 0 makes this go away. 0 makes this go away. I'm just left with negative 3. So there's 0, negative 3. And then all I did from there was, I know that this line right here is like my mirror. So I just counted how far away is it from the blue line. It's 1 to the left. So the mirror would go 1 to the right. So I just went boop, over to the other side to make it symmetrical. And then I just went, that's 0.2, -3. That's the coordinates of those points.
Oh, okay.
So they are the same point on both sides of the line.
Yeah.
So you only have to do, the good thing is you only have to do one. You automatically get that mirror point just by looking at the graph.
Okay.
Good question. All right, how are we feeling so far? Feeling okay? I know, me too. Don't worry, and well, not tomorrow, probably the next day, I'll show you a cheat. I'll show you a shortcut, and it'll be way better than this. Okay, let's flip it over to the back. Okay, we're gonna skip the other graphs. We're gonna we're jumping down to the part that says the discriminant.
Why?
Why? Because you know how to graph, you believe me.
Now I'm talking to him.
Oh, okay. All right. We're jumping down to the bottom, so flip it over.
Flip it over.
Okay. This next part, so I'm going to skip the rest of the graphs. I'm coming right down over here because you'll practice the graphs on your own. The next part is called the discriminant. Has anybody heard that word before?
I have not heard that word.
So maybe not. The discriminant is just something that we use to determine how many solutions that there are. So without graphing, you already should know how many solutions there are. So it's a good way to just check your work. So the discriminant right up here, it is used to determine the number of solutions. So that way, when you go to graph, you should know how many times it crosses the x-axis without even graphing your picture. Okay? So our formula is similar to our axis of symmetry. It's another part of something called the quadratic formula, which I'll teach you later this week. But the formula for it looks like this. D equals, so D is the discriminant. Everyone say discriminant.
Discriminant.
Discriminant. Say it again. No one said it. Discriminant.
Discriminant.
There you go. Okay. The formula looks like this. B squared minus 4AC. B squared, excuse me, minus 4AC. If when you do this little equation, if your D value is bigger than 0, so it's a positive number, that means there are two solutions. So your graph should cross the x-axis twice. If your D value is equal to 0, so it comes out to nothing, then there should be one solution. So it'll cross the graph one time on the x-axis. And if your D value is less than 0, take a wild guess, how many solutions are there?
How would you put that in the calculator?
Well, there's none. So there's only 3 different ways you can have it. You can either have 2 solutions, 1 solution, or no solutions.
1.
Well, we already got 2 and 1, so the last one has to be
0.
no solutions or 0 solutions. That's right.
Wait, so is D going to be provided?
No, D, you're going to have to solve for it. But that's what I'm going to show you how to do right now. What? Select appropriately, friends. Okay, ready? So here's all we're going to do. We're going to write down A, B, and C, and then we're just going to plug it into the equation. So let's take a look at number 7. What is your A value in number 7?
1, 5.
1. Your B value is 5. I'm going to assume we're chatting because you're already ready for this and you could take a quiz on this right now. Yeah? Okay, then we shouldn't be chatting. Okay. A value is 1, B value is 5, C value is 4. We're going to take those, we're going to plug them into the equation, and then without graphing, I already know how many solutions there are going to be. All right, so here's the equation. B squared minus 4AC. So instead of B squared, what am I going to write?
5 squared.
5 squared. Good, so I'm substituting in the 5. For the B value, 5 squared minus 4 times A times C. So this is multiplication. So 4 times,
1 times 4.
good, 4 times 1 times 4. And then it's just a little bit of algebra. Which piece should I do first?
The squared.
The squared. What is 5 squared?
25.
This is 25. Now this is where you might want a calculator. What is negative 4 times 1? Negative 4. And then what is negative 4 times 4?
Negative 16.
Negative 16. Now, what's 25 minus 16?
9.
This is 9. Okay, so your discriminant is 9. Now, come back over here. Is 9 greater than 0?
Yes.
Yes. So how many solutions are there?
2.
There are 2 solutions.
So just put 2 solutions.
Yep. So if I asked you to graph it, it would cross the x-axis twice. This is a positive graph. It would look something like this. Whoop. Crosses it twice.
That's the fast way?
That's one of the fast ways, yeah.
Oh.
Yeah.
Can you do that way?
Of course you can. Of course, that's why I'm teaching it to you.
But can we do that way on the graph or not?
Well, if I ask you to physically graph it, then you have to graph it. But if I just say how many solutions are it, you don't have to. You could just do this. Oh, because my D value is 9
Oh, okay.
when I solved. Yeah. Once you solved, the 9 was bigger than 0, so there are 2 solutions. All right, you ready for the next one? Where are we done in here?
I like this way.
Right. And then the one I'm going to show you, not tomorrow, but the next day is even easier. So it's just going to get better from here. Okay.
Same way.
Same exact thing. What's your A value for number 8?
1 or negative 3 and 2.
1, B is negative 3, C is 10. Okay, we're going to plug it into the equation. B squared minus 4AC. So instead of B squared, what am I going to write? Good, negative 3 squared minus 4 times A times C.
1 and 10.
1 and 10. Good, so you definitely want a calculator. What do I do first? Good, negative 3 squared. That means negative 3 times negative 3. Good, that's 9. Positive 9. Now,
And then negative 4 times negative 10.
well, first do times the 1.
Oh, okay.
Negative 4 times 1 is just
Negative 4.
negative 4.
Then it's negative.
And then negative 4 times 10 is negative 40. You can put the whole thing in your calculator. You know that, right?
I thought you said it'll do just distributions like that.
It will do that because that's just straight across multiplication. If you try to put the whole equation in with the 3 squared, it won't know to do that because that doesn't know order of
I got
operations.
negative 31.
Okay,
Negative 31.
negative 31. So now, let's come back to the little piece here. Is negative 31, is that bigger than 0?
Yes.
Oh, wait, no, it's not. Sorry, I forgot.
No. It's a negative.
No.
No, it's negative. It's not bigger than 0. It's a negative number. Is your discriminant, is that equal to 0?
No.
No. Is it less than 0?
Yes.
Yes. So how many solutions are there?
0.
No solutions. And that's it. No solutions. Way better, right? Way better. Okay. We've got about 5 more minutes. I want you to do just those last 4, okay?
And then come back.
And then we'll realistically, that'll take us to the end of the period, and then we'll check those 4 tomorrow, okay? But I just want you to do these ones down at the bottom. You got enough time to do them right now. So do those 4 right now, and then we're done for the day. Good. No, there's 4 minutes left. Careful with signs.